Hi students, good evening. Hope you are faring well. You are welcome back. Let's continue from where we ended. Today we are going to treat the topic in circular motion, arc length or arc distance. An arc length or arc distance is represented by the symbol S. So I have my S over here. Now, to understand this very well, let us consider a body performing circular motion. So let's say you have it this way, and let's say the body is at A, moving towards point B. Let's say you have the center here, and now you know that any line drawn from the center to touch any point on the circumference of the circle is known as radius. So it means the line drawn from the center to touch the circumference is what? My radius. And when I extend this, when I draw the line to touch the circumference at A, is also my what? My radius. And you know, as the body moves from point A to point B along the curved path, there is an angle described by the body. Are you okay? So, and the angle described by the body is the angle theta. And in my previous lessons, we talked more on the angle theta. And we said the angle theta here refers to what we call the angular displacement. I hope you haven't forgotten. And now, suppose the body is moving from point A out to point B along the curved path. We are saying that the distance moved or covered by the body as it moves from A to B is represented by the symbol S. So clearly, S is our arc length or our arc distance. Please note the difference between the theta over here in the diagram and S also. S refers to, or S is a distance, whereas the theta refers to what? It is an angle. So please note this, S is basically a distance, while the theta or the angular displacement here is what? Is an angle. Please, are you okay? So here, my theta here is my angular displacement. My angular displacement, and my S is my arc length. So how can you define an arc length? I don't expect you to chew this. Are you okay? So you can say that arc length refers to the distance traveled by the body as it moves from A to B. With respect to the diagram, that's arc length for you. You can say arc length is the distance traveled by the body or by a body as it moves along a curved path. You see, it's very, very simple. So I don't expect you as a student to chew this. Now, let us proceed to the next level. Okay, so now, let's look at the relationship between S and the angle theta. How are they related? And now you realize that let's say if I have these two markers, I have a red marker here and a black marker over here. When I place one on top of the other this way, realize that the angle between these two markers is 0, because there is no angle between them. So therefore, the angle between these two markers is equal to 0. But when I begin to open up the markers, open it appreciably, I keep opening it, you realize that there is an angle formed between this red marker and the black marker. And that angle here is what I'm calling the angular displacement, or the theta, which is over here. And now, the distance from here, from the tip of the red marker to the tip of the black marker, I'm calling it S, and this S here is my what? Is my arc length. So now what happens if I extend the arc length or the distance? You realize that as I extend or open up the markers, what is happening to the size of the angle? The size of the angle what keeps increasing. Please, are you okay? And what happens to when I close up these markers? When I close up the marker, you realize that the angle or the angular displacement here becomes so small. And as the angle becomes small, the distance between the two markers too also what keeps decreasing. Please, do you get the assertion over here? So it means as S increases, my angle over here will also increase. But when the angle decreases, the arc length also what decreases. And you know that in math there's a topic called variation, and particularly we have what we call the direct variation, which talks about two quantities relating to each other. If we have two quantities such that when one quantity increases, the other one also increases, or when one quantity decreases, the other one also decreases, we call it direct variation. Please, are you okay? So as one is increasing, and the other one is also what? Increasing. And when the same quantity is one is decreasing, the other one also what? Decreases appreciably. Are you okay? So now, so because when S increases, theta also increases, or when theta also increases, S will increase. So that means this is what? Direct variation. And we say that S is directly proportional to the angle theta over here. Please, are you okay? And you know that you cannot work with the proportionality sign here unless you change the proportionality sign to an equal to, then you replace it with what? With a constant of variation. Are you okay? So now let us consider this. Let's say if you have a circle over here, this is my center. A line drawn from the center to touch the circumference is what? Radius. From here to here is my what? Radius. From here to here is my what? My radius. From here to here is what? Radius. From here to here is what? Radius. From here to here is what? Radius. Provided it is from the center to touch any point of the circumference, it will render it a radius. So from here to here is what? My radius. From here to here is my what? My radius. From here to here is my what? My radius. What can you see? You can deduce something from here. You realize that the radius is not changing. In other words, the radius is constant. Because here is radius. When I come here, it is not something different. It's still radius. It keeps what? Repeating itself. So it is constant. And now you know that in the direct variation, so first I have this, it will be S is equal to K then theta, where K is the constant I have what? Introduced. But realize that here, from what I did earlier on, what was constant? It was my radius. So I'll rather put R here, where R is my constant of variation. So finally I have S to be equal to R theta. This is one big expression, or a relationship connecting the arc length or the arc distance. So here my S is my what? Is my arc length. My R is my radius. Then my theta here is my angular displacement. Yes. So this is the end of the lesson. I hope everything is understandable. Thank you. Learn hard. I will meet you again. Goodbye.